Are you curious what a photographic film is? Well, a photographic film, when exposed to light, generates or records an image. This can be seen in traditional photography and also in radiology. One of the layers of an X-ray that is invisible to the naked eye is a photographic emulsion. Images are made and preserved in a medium called emulsion. X-ray film consists of a polyester substrate coated with gelatin. The film is coated on both sides with an emulsion containing silver halide crystals sensitive to different wavelengths of light: X-rays, gamma rays, heat, moisture, and pressure. If an X-ray film is outdated, it should not be utilized since the image quality may suffer significantly due to fogging. X-ray film is very much like the traditional photographic film in its composition. This double emulsion film has a transparent substrate coated on both sides with a radiation-sensitive emulsion. A thin coating adhesive is applied to ensure a secure bond between the emulsion and base. A thin layer of gelatin, termed supercoating, shields the photographic emulsion from damage caused by scratches, pressure, or contamination. Again, the photographic film or emulsion is used to detect and monitor cumulative radiation dose. Its sole purpose is to measure and record radiation exposure from gamma rays, X-rays, and beta particles, since it is worn by the person being examined and/or the personnel who would be on duty to use radioactive materials. Now the film badge will be able to accumulate the amount of radiation to which the wearer has been exposed. The importance of these revolves around science and patient or personnel care. These are: 1. The accumulated dose monitoring recorded is designed to bring comparison to the field of measurements. The doses that were processed by the film in the recorded amount will be used for future reference in the practice. It will be a guide for experimentation and activities in the field. 2. The results are for assessing the potential long-term health effects of the radiation on the wearer. Since gamma rays, X-rays, and beta particles, which are considered dangerous in a threshold, are involved in the process, the results from the monitoring are used to assess if the amount of those may create or produce induced health effects on the wearer. This is important in reference to the first pointer of importance. Let us tackle about its advantages. 1. It is portable for radiation workers to carry because it is light. 2. It is a radiographic film itself. Consider it to be a standard radiographic film that is being exposed to ionizing radiation, such as X-rays, gamma rays, and a small quantity of beta rays as it interacts with it. 3. It is maintained by a monitoring company as a permanent legal record of radiation work or exposure. 4. It is reasonably economical and cost-effective per unit each month. 5. It has high mechanical energy properties and will not be easily destroyed if dropped accidentally by a radiation worker. 6. A developed film dosimeter provides a fairly permanent record of an exposure that may be reviewed in the future. 7. When used in pairs, film dosimeters provide enough sensitivity to cover a broad range of predicted exposures. Let us tackle about its disadvantages. 1. Relatively high temperature and humidity, as well as getting wet, can cause the film to fog up over time. So, there will be an accuracy of radiation exposure reading. 2. It extends the amount of time a radiation worker has to wear the badge, which could lead to a very inaccurate high radiation exposure reading. 3. The film badge must be sent to the monitoring company so that it can be processed and determine its exposure. 4. After 1 month of occupational exposure, the film is chemically processed under strict temperature, chemical concentration, and timing controls. 5. It has issues with waste disposal. 6. Its sensitivity goes down when the energy level is above or below 50 keV. 7. Film dosimeters can only be used once. And that's how a photographic film works. I hope you learned something today.